Okay, happy Friday, everybody. Go ahead and get out your free response packet. So if there was a snow day, I'm recording this on Thursday, so if there was a snow day, you should have completed this at home. If there wasn't, we completed this in class yesterday. So either way, you're going to be getting this handed to you. So I'll wait just a minute for that to get handed out. Okay, so you should have this free response in front of you. Hopefully you're pretty familiar with it because you've spent your 15 minutes on it. So we're given this graph. We're given the graph of g of x. It says the graph of the continuous function g, the derivative. Oh, that's interesting, okay. It says that g is the derivative of the function of f. Well, let's label that then. We know that this is the graph of g of x, which equals f prime of x. That is the derivative function. It's shown above. It says that the function g is a piecewise linear for -5 to 3. So that just means that it's piecewising linear functions. That's just a straight line from -5 to 3. And then it says that g of x is equal to 2 times x minus 4 squared, which is a quadratic, anywhere from 3 to 6. So that's important. All right, so letter A says, if f of 1 is equal to 3, what is the value of f of -5? Okay, so there's a couple ways to think about this. Either way, you are going to use the fundamental theorem of calculus. So either way, you're going to use the fundamental theorem. What they're saying is that I know f of 1, and I want to know f of -5. Well, here's my first strategy. Well, if I want to find f of something, what I'm given is f prime. If I'm given f prime and I want to know f, then in order to go from a derivative back to the original, I need to take the, that's right, integral. I need to take the integral. So this is my first strategy. If you used a different strategy, that's fine. Either way, you're going to get the same thing, hopefully. But I'm going to take the integral from 1 to -5. Sorry, from -5 to 1. I want to go lowest to highest. And I'm going to use the fundamental theorem of calculus to derive f of 1 and derive f of -5. So you'll see what I'm talking about here. If I take, so this is for letter A, I take the integral from -5 to 1 of the function that I know. The function that I know, the one that I have a graph of, is g of x. Is g of x dx. If I take that, using the fundamental theorem of calculus, what is the integral of g of x? Well, let's rethink about this for a minute. G of x equals f prime of x. So let's rewrite it again. This is the integral from -5 to 1 of f prime of x dx. Using the fundamental theorem of calculus, what is the integral of f prime? Well, the integral undoes the derivative. So the integral of f prime of x is just going to be f of x. But in this case, we want to evaluate from the upper bound to the lower bound. So this is going to be f of 1 minus f of -5. Okay, so from here, we need to go ahead and take the integral using my rectangle method or just using the area under the curve method. And I actually already know what this one here is. It says that f of 1 is 3. So let's go ahead and rewrite all of this. Let's solve for f of -5 so I can put everything together here. So if I solve for f of -5, say I subtract f of 1 on both sides, minus f of 1. Well, I'm going to get this. The integral from -5 to 1 of f prime of x dx, that's the same thing as g of x, minus f of 1 is equal to -f of -5. If I totally solve for this, I'm going to get rid of this negative symbol here, and I'm going to move f to the other side, f of 5. So I'll say that f of -5 is equal to, if I multiply everything by -1, it is equal to this. I'm going to put f of 1 up front because it's, anyway, -1 times negative is positive, so I'll say f of 1 minus the integral of -5 to 1 of f of x dx, f prime of x dx. Okay, So through other means, you might have already gotten this because you realized, hey, if I'm starting off at 1 and then I'm going all the way back to -5, you could have derived this on your own, but this is how we get this using the fundamental theorem of calculus. I know that f of 1 is 3, so I know that f of -5 is equal to 3 minus the integral of -5 to 1 of f prime of x dx. All right, so what is the integral of f prime of x dx? Well, we know that f prime of x, that's the same thing. It's the same thing as g of x. So what I need to do is look at my graph and determine what is the area under the curve from -5 to 1. What's the area under the curve from -5 to 1? So if I take a look at my curve here, from -5 to 1, let's start from -5 just to 2. -5 to 2 is a rectangle. -5 to 2 is a rectangle. It's going to have a negative net sum area of 3 times 3, which is 9. So we'll say that f of -5 is equal to 3 minus, well, our first piece is -9. And I also have another negative piece. This triangle here is going to be 1/2 base, which is 1, times height, which is 3. So we'll call this minus 1/2 base 1 times height, which is 3. From -1 to 0, I don't have any volume at all. Not volume, area. But from 0 to 1, I have a positive area of 1/2. This is a triangle, so that's a triangle there. 1/2 base times height. Well, the base is 1 and the height is 2. And so I'm going to say plus 1/2 base times height. So if I do a little bit of simplifying here, we are going to get 3 minus the entire quantity of, we'll go ahead and put this together. I'll just put this all together, it's fine. Minus 3/2 plus 1. 9 minus 3/2 plus 1. So if I simplify that some more, I'm going to get 3. Let's put these together. That's minus 8. So I'll say 3 plus 8 plus 3/2. 3 plus 8 plus 3/2, which is 11 plus 3/2. That's 11. 11 over 2 is the same thing as 22. If I put it over 2 is 22 over 2 plus 3 over 2. We should get 25/2 there. All right, so that is the answer for letter A, 25/2. Let's go ahead and keep on moving. Let's move down to letter B. Okay, so letter B says evaluate the function, evaluate the integral, B, evaluate the integral from 1 to 6 of g of x dx. This is a pretty easy question. This should be pretty self-explanatory. All I need to do is find the area under the curve from 1 to 6. So let's start from here. Pretty easy at the beginning, pretty easy go at the beginning. The first area is going to be a rectangle. Well, it's actually a square, but same thing. It's going to be a rectangle here. This is going to be an area of 4. So we'll say the first one, we could even split it up. It's the integral from 1 to 3 of g of x dx, and then we'll deal with the other thing later. And then from 3 to 6, g of x dx. So the integral from 1 to 3 is going to be 2 times 2, which is 4. It's got an area of 4. And now I need to find the area under the curve for 3 all the way up to 6. Now this is not going to be as easy as me just using some sort of geometric formula. I actually need to find the legit area under the curve for this quadratic. That would be really hard to do, except, oh, they gave it to me. They say that this curve right here is 2 times x minus 4 squared. So I want to know what's the integral from 3 to 6 of 2 times x minus 4 quantity squared. Okay, so we could just use u substitution here. I hope at this point some of us can see what the answer is to that relatively quickly. If you don't, you can use u substitution later. But what we can identify here is that if this was a u substitution, I would say that u is the inside here. It's x minus 4. du would be 1 dx. And so I could make this whole thing, I could replace this whole thing. I'm going to take this 2 up front. We'll say plus 2 times the integral of x minus 4 quantity squared dx. I'm going to replace what I know. So this is 4 plus 2 times the integral, of 3 to 6, of 3 to 6 of u squared du. So hopefully, if you hadn't seen this already, this thing is just going to be squared, which means its antiderivative, or its integral, is going to be raised to the 3 divided by 3. So this will be 4 plus 2 times my new function raised to the 3 divided by 3. And that's going to be evaluated, this is a definite integral, from 3 to 6. So pardon me skipping a step here, but I am going to just replace u at this point. U is x minus 4. So hopefully you can see at this point that it was literally the same thing as me taking the integral of just an x. X squared, the integral of that is x cubed divided by 3. This thing is the same thing, except it's x minus 4. It should be the same thing. So from there, we're just going to evaluate. In fact, I think this video is probably getting a little bit too long, so I'm just going to tell you what this is. If you were to evaluate this here, you would get 10. You would get 10, okay? All right, so let's go ahead and move on. Letter C. So letter C says this. Letter C says this. For between -5 and 6, on what open intervals, if any, is the graph both increasing and concave up? Where is the graph both increasing and concave up? So all the way, the entire interval. Let's take a look at this and let's see. We need to keep in mind that this graph is the derivative graph. This graph is the derivative graph. So I want to know, where is f, okay? Well, what I have here is f prime. I have f prime. So when is f increasing? So think to yourself, what does the derivative do? What does the derivative of f of x do when it's increasing? Well, I know that f prime of x is greater than 0 when f is increasing. So we need to only look above the x-axis. In addition to that, I want to know, where is it concave up? Where is it concave up? So in order to know where it's concave up, what is f prime of x doing when f is concave up? Remember, we took a little quiz on this a long time ago. But we know that f prime of x is increasing. F prime of x is increasing when f is concave up. So here's what I'm looking for. I'm looking for above the x-axis, and I'm looking for increasing. I'm looking for positive slope. So take a look at your graph and see, where is it increasing? Where is there a positive slope? I'm gonna grab my highlighter for this. Okay. So it looks to me, it's above the graph, it's above the x-axis and increasing here. And it's above the graph and increasing here. So we can say that the graph is, that those solutions, I guess, are satisfied when x is between 0 and 1, and when x is between 4 and 6. And I know that because f prime of x, it equals g of x. We already know that, we wrote that. And we know that that's where it's greater than 0. We also know that f prime of x, which equals g of x, is increasing on these intervals too. Is increasing on those intervals. Okay? All right, let's go ahead and let's move on to the very last question. Our very last question shouldn't take us too long. It's along the same lines. It says, find the x-coordinates of each point of inflection of the graph of f and give your reason for an answer. So let's think this through. When in the world do I have a point of inflection? Well, the point of inflection happens when f double prime of x is equal to 0. But what does that imply for f prime of x? What does that imply for f prime of x? If f prime of x is doing what, then f double prime of x is 0. Think about that for a minute. Okay, so we should be thinking, okay, the derivative of this graph is 0. If the derivative of f prime of x is 0, that means that I either went from increasing to decreasing or decreasing to increasing. In essence, I have a horizontal tangent line. So really what I'm looking for here is any place that I have a min or a max. I'm looking for a horizontal tangent line. That's what I'm looking for. I want to know, when am I directly going from increasing to decreasing? Now you might be tempted to think that right here, 1 to 3, well, I guess I'm going from increasing to decreasing at some point. But is there a distinct moment when I go from increasing to decreasing here? The answer should be no, because I am increasing all the way from 0 to 1. But when I get to 1, I'm neither increasing nor decreasing. My slope is 0. So this actually right here, this is not a point of inflection. What I'm looking for is a point where I go definitively from increasing to decreasing or decreasing to increasing. So the only place that happens, that happens on my graph is actually right here at 4. It can't happen here because I'm going from 0 slope to positive, so that doesn't work. I'm going from positive slope to 0 slope, that doesn't work. 0 slope to positive slope, that doesn't work. Positive slope to 0 slope doesn't work. 0 slope to negative slope, that doesn't work. But here I am going from negative slope to positive slope. So lastly, for letter D, we can say that the graph of f has a point of inflection. It has a point of inflection at x equals 4 because, and they asked for this is the reason, this is our extra point, because f prime of x changes from decreasing to increasing here, decreasing to increasing here. All right, that is it. I'm not sure if you guys are watching this at the beginning or end of class, but I hope you guys have a wonderful weekend. See ya.